Good morning, good afternoon, ladies and gentlemen. Welcome to the webinar Complete Workflow for Steel Buildings. I am Swarup Mondal, Senior Business Development Manager from Bentley Systems and your host for today's webinar. Along with me, I have my colleague Madan Elumalai, Senior Technical Manager, Engineering Simulation of Bentley Systems. Today we will discuss on Bentley's most comprehensive solution, Structural Worksuite, that effectively manage all of your structural projects using complete and integrated workflows. Let's talk about today's agenda. Firstly, we will discuss about Virtuosity and practitioner licenses, followed by an introduction of Structural Worksuite. We will focus on steel building analysis, design and detailing workflow per Euro codes. Then floor vibration check, connection design, BIM interoperability. We will have the Q&A session after the presentation. Virtuosity is the new online platform of Bentley Systems that gives you an easy way to purchase Bentley products through practitioner license. It offers competitively priced, industry-leading products with expert training and makes it quickly and easily available for purchase online. Virtuosity provides Virtuoso subscription with keys and each purchase that can be used for expert services and training that you need to take your project to the next level. The number of keys received with each subscription varies based on the software you purchase. The keys provide an add-on value to Virtuoso subscribers with exclusive rights to the tailored training materials built specifically to help you work more efficiently. With the keys, you can choose our wide range of expert services or training, such as virtual classroom training, on-demand sessions, standard and customized training, consulting, and mentoring services to build the support program needed for your engineers and designers. Our expert services will help improve your design, analysis, and modeling skill to help increase productivity and reduce time away from project work. Virtuoso subscriptions are offered exclusively from virtuosity.com. You can check it out today. Just visit virtuosity.com, choose the right product, and you will find a new experience. It's so easy. Select the particular product that you need, complete the purchase from your secured online shopping cart using a preferred payment method. Upon processing, you will receive an email to register and access your practitioner licenses and training. You can look at the QR code on the right side. You can scan and straight away it will bring you to the site. Okay. Now, the benefits of the Virtuoso subscriptions are many ways. You can get the expert services. You can also get the technical support 24/7 basis. And during the 12 months, you will get all the product updates and upgrades. It's a simple process in ordering. There is no paperwork required, and there is no question of any excess uses. And pricing is transparent. You can just visit and see the pricing. And it's applicable for all clients, existing or even new users. So within 24 hours of ordering, you can install the software, and after that, within 12 hours also you can request for the expert services. So let's proceed with the presentations. I would like to invite my colleague Madan Elumalai for the presentation.
Okay, greetings engineers. Welcome to this today's presentation on complete workflow for steel buildings. My name is Madan Elumalai, today's presenter. Basically, I'm a civil and structural engineer working with STAR products for almost 25 years and RAM products for almost 10 years now. Okay. Before I start my presentation for today, I would like to have some polls. So please participate in this poll. The first question is, are you doing commercial, residential, high-rise, medium-rise, low-rise steel buildings? Okay. So when I say steel buildings, is commercial, residential type of buildings. Okay, not really industrial. High-rise, low-rise, medium-rise buildings. Okay, so I'll give you 10 more seconds by answering this poll. So please help us participating in this poll. I see only 65% of you have attended this poll. So please help us answering this poll so that we can know the type of audience attending this webinar. Okay, so now almost 80% of you voted. So I'll close this poll and we'll move on to the next poll. What structural analysis software are you using for this building, steel building type of projects? Okay, commercial, residential, steel building projects. So I have listed some commonly used programs that include special purpose building analysis and design programs, also general purpose structural analysis programs, to get an idea about your current usage of structural analysis program for steel buildings, commercial, residential steel buildings. Okay. So please help us in answering this poll to get an idea about the type of audience. I see almost 70% answered this poll. I strongly encourage others also to participate in this poll. So majority of you, the reason why I have this poll is to get an idea of how many of you are using a general purpose program to do a special purpose building. Okay, so as I expected, 69% of you have mentioned that you use StatPro. 73%, 75% approximately voted for this poll. Okay, and out of that, 69% voted for StatPro. And as I expected, okay, so you are using now the percentage increased to 70%. You're using a general purpose program to do a commercial steel building. Okay, high rise, low rise, medium rise steel building. Okay, what my recommendation or my suggestion here is to look into a special purpose program which is specialized for buildings. Okay, like RAM structural system. That is what my entire presentation for today is going to be. Rather than using a general purpose program like StatPro to do your steel buildings, if you use a special purpose program like RAM structural system to do your steel buildings, you'll be at least 4 times faster. Okay, that is the message I want to give you out of this poll. Okay, thank you. So with that, I'll close this poll and then let's move on to our today's presentation and complete workflow for steel buildings. Hope all of you are able to see my full screen. Okay, so the synopsis for today's presentation is traditionally, many architectural engineering construction companies use different vendor software products for modeling, analysis, member design, connection design, detailing. And when it comes to detailing, it is design drawings, sometimes construction drawing also, and quantity estimation, cost estimation for steel building projects. Okay, so you may use analysis from one vendor, analysis software from one vendor, connection design software from one vendor, and some of you even use spreadsheets. Okay, and for detailing you use another software. So different vendor products. Okay, so the trouble lies in the interoperability of these different vendor products that kills the benefits of BIM. Okay,
Madan, can you share your screen? Yeah.
I see. My screen is frozen.
No, now it's okay. Now can see.
Now
Yes.
it's okay. Sorry for that.
Yeah.
Okay. Can you see my screen now?
Yes.
Okay. So traditionally, many AEC companies use different vendor software products for modeling, analysis, member design, connection design, detailing, and quantity estimation for steel building projects. The trouble lies in the interoperability of these different vendor products that kills the benefits of BIM. BIM is a process, it's not a product. So in order to make this process successful, smooth interoperability between the above software is important. So Bentley's structural worksheet provides a solution. So what is Bentley's structural worksheet? It's not a product. This is a special bundle license of 8 products from STAR and RAM brands. As you can see, the 8 products on the screen, number 1 is STAR Pro Advanced, which 69% of you today answered that you're using it for steel buildings. Okay. Notice that STAR Pro is a general purpose structural analysis, design and detailing program. And for buildings, steel buildings or concrete building, I would suggest you to use the 4th program, RAM Structural System, which is a specialized program for specialized structural analysis and design program for buildings. Okay, and today's presentation is more focusing on this RAM Structural System and the 6th program, RAM Connection. In my last month webinar on concrete buildings, I focused on 3 products, RAM Structural System again, and then RAM Concept, the 5th program for slab and mat foundation design, and RCDC from StatPro. So it's actually 2.5 programs I used in my last month webinar for concrete buildings. Okay, and today, since it's on steel buildings, I focus on RAM Structural System and RAM Connection. Okay, maybe some other day we'll look into the other programs. So the design codes coverage, you can see Eurocode, that's what we use it in Singapore and Malaysia, is covered in 5 out of all these 8 products. Okay, StatPro has the Eurocode Singapore National Annex for both steel and concrete, and the Australian AS 3600 2018 code will be available in Q3 this year. Okay, the steel code is already there in StatPro. It's just the concrete code which will be implementing in the next quarter. Okay, this year. And other than that, today's program, RAM Structural System and RAM Connection, both as the Eurocodes. And the US code also, the Australian code also available. Okay, New Zealand code is also available for StatPro and RAM Connection. But for RAM Structural System, we do not have a New Zealand code. We only have the Australian steel code. Okay, and once the AS 3600 2018 is implemented in StatPro Advanced through the RCDC, the same RCDC can be used together with RAM Structural System also. Okay, so those are the code coverage. So the big picture you can see here on the left side, all the 8 products of structural worksheet can communicate to each other through this ISM plugin. ISM stands for Integrated Structural Modeling, using which you can interoperate the models from any one of the structural programs to a BIM program like Autodesk Revit or Tekla Structures or Bentley's Open Building Designers or Pro Structures. Okay, so the highlighted ones are all included in structural worksheet. So since today we are going to cover more on RAM products, RAM Structural System and RAM Connection, let's have an overview of these RAM products. Okay, so what structures are designed using RAM brand of products? As you can see on the screen, office buildings, residential buildings, education campuses, medical campuses, public, retail. These are the building type of structures which RAM brands handle. Okay, and notice that there's no industrial buildings are covered here. That's where StatPro is used, and infrastructure type of projects. That's where StatPro is used. Okay, so when it comes to high-rise, medium-rise, low-rise, steel, concrete buildings, composite buildings, that's where RAM brand is used. So what type of structural systems? Structural steel, reinforced concrete, post-tension concrete, timber, masonry, and foundations. Timber and masonry, you can also do it in RAM brand of products in RAM structural system as well as RAM elements. So why to use RAM? RAM products are custom made for buildings. Unlike StatPro, which is a general purpose program, RAM structural system particularly is not a general purpose program. It is a special purpose program for buildings. So why do I say like this? Because the modeling is very easy and is fully optimized for buildings. The application of loads, particularly the implementation of building codes such as a live load reduction code, wind load code, seismic code, as per the local code that you follow in your country is fully implemented in this program. And extensive automation of tedious and time-consuming tasks like alternate span loading for one-way floor is all done automatically in RAM structural system. If it is a two-way floor, the pattern loading is automatically done in RAM concept. So these extensive automation and time-consuming tasks are all automated here in these programs. Okay. So basically, RAM suite consists of these four products: RAM structural system, which is for 3D analysis and design of buildings, and RAM concept, which is a specialized program for slab and mat foundation, including post-tensioning, RAM connection for structural steel connection design, RAM elements for design toolkits for structural components like retaining wall, single beam, single column, continuous beam, single isolated footing, single pile cap, etc., etc. So on the screen, you can see a 4-story building. The bottom 2 floors are concrete. The top 2 floors are steel. The bottom floors are having flat slabs without beams, and the top floors were having composite floors and non-composite floors. So you can see the different modules of RAM are used for designing this 4-story building. And you can also see the shear walls with openings. And the modeling is all physical modeling. Who uses RAM? Structural engineering consultancies, AEC firms, EPC organizations, building contractors uses RAM brand of products. Here's the words from the technical director from WSP, who is our largest user for RAM structural system and RAM concept. As soon as there is a new building, a new project, we know that this is a part of RAM concept, which is a part of RAM structural system. Every engineer in the company knows how to use these two software applications and how to push them to their limits to achieve efficiency in our design. So this combination of these two programs, RAM concept and RAM structural systems, is a very good combination for concrete buildings. And for steel buildings, RAM connection and RAM structural system combination is the best. Here you can see a case study for steel buildings, which is a medical center in the United States in Missouri. So Stanley, Lindsay and Associates are the consultants for this project. This is a 425,000 square feet, 250 bed hospital designed to add 50 more beds in future. US dollar 173 million project. What is so special about using RAM structural system for this steel building project? On the left side of the screen, you can see members showed in red color, blue color, yellow color. Okay, this is a completely steel building except the foundations. You can see the red color members are lateral members, and the blue color members are gravity members. The yellow color members are gravity, but they are composite beams. Okay, so by the ability to model both lateral and gravity members makes this RAM structural system a specialized product for buildings. This way, the engineers has more control in distributing your lateral loads to the lateral framing system. In case of steel buildings, it is the lateral frames with the bracings. In case of concrete buildings, it could be the shear walls that takes most of your lateral loads. So this way, when you model a beam or a column or a wall, the program will ask you whether it's a lateral or a gravity member. Okay, depending on whether you choose it as a gravity or lateral member, the color will show as a blue or red. Okay. Next, let's see the modeling overview. I'm not going into detail about the modeling because last month I covered well about the modeling features in the concrete building webinar. And today I'm just going to show you the overview of the modeling using the RAM modeler. So this is what you see in the first screen of RAM structural system. On the bottom right side, you see the 4-story concrete building, steel building. And here's the first screen where you specify the criteria. I have chosen the Eurocode Singapore National Annex for live load reduction. And you can see the presence of other live load reduction codes such as BS6399 as well as the Australian code and Indian code as well as the American codes as well. Next, the self-weight criteria. I have specified that the program should calculate the self-weight for all the structural components that I model in this project. Next is the master steel table. I use the RAM UK steel database for this project. And you can see the presence of other steel tables in this program. Depending on the project, you can set up your master steel table and design steel tables correctly for decks, columns, beams, cellular beams, joist, and buckling restraint bracings as well. Okay, so for this project today, I'm using the British sections. And here are the Eurocode factors where we can fine-tune this table to suit your local national annexes. Okay. So next we'll go to the RAM modeler, and there you can see the plan view of my 4-story building, which has 4 different type of floor layouts. And the floor, the deck slab, I'm using composite floor, Tata Comfloor 80. Okay. So depending on the master steel table you have chosen and the design steel table, this composite floor system library will be automatically using the library of that particular country standard. Okay. And here's the grids that I used for this example. So the X direction grids, I have a 9.75 meter spacing between the grids, that is A, B, C, D until I. Okay, so 78 meter till 78 meter grid spacing of 9.75. And similarly in the Y direction, the grid spacing is 9.14 meter spacing, so which is really a very high spacing. And that's why we need to go for a composite flow. Okay, so you can see here the 3D view of the 4-story building. And here you can see red color members and blue color members and the composite floors for all the 4 floors. And the foundations are all the pile caps. And the openings are for the staircase or lift. So every direction I have this red color lateral framing. Okay, so I switch off the slab, I switch off the gravity members. Now you are seeing only the lateral frames. So these lateral frames takes all the lateral loads. So only these lateral frames need expensive moment connections. Remaining all the hundreds and thousands of gravity members just require simple shear connections. That's what makes this program special. So what happens when you have lateral loads applied on gravity members, such as wind load? They simply lean towards the stronger lateral members, and the lateral members takes all the lateral loads, and hence they need a stronger section and moment connection. Okay, so we are viewing the elevation view now. You can see the red color members, lateral members, and the blue color gravity members. Okay, I switched off the gravity members. Now we can see only the lateral members, and only for the lateral members we need to specify a proper size. Okay, so that's where the user need to give the size only for the lateral members. For gravity members, the program will select a suitable size automatically. It's only the lateral members the user need to specify the size. So you can see I have used the UB sections for beams and columns. For columns I use UC sections, and for beams I use UB sections. British universal beams and universal columns. Okay. Okay, so that's about the overview about simple overview about this 4-story steel building, lateral and gravity member modeling. That is the key theme in this RAM program. Next, let's see the gravity loads. How do we model the gravity loads? Again, in RAM modeler, we model the gravity loads. Okay, going to the property table and loads. So I have surface loads, line loads, point loads, snow load. Okay, I already created some surface loads for the office region, which is used for the intermediate floors. I use a dead load of 3 kN per meter square on top of the self weight of the beams, columns, and walls, which we already modeled. Okay, and I modeled some construction dead loads as well as live loads and construction live loads, partition wall loads, and the mass dead load for the response vector analysis. Okay, the mass dead load I calculated by computing 100% of dead load plus 50% of live load. Similarly, for the roof, I have some reduced dead loads and live loads. So this is how I model the gravity loads. And then I assign these gravity loads using the layout option, load surface loads. Okay, I already assigned this office load and roof load. And here I am showing you this gravity loads. It's a simple application of gravity loads using the RAM modeler. And the same thing I'm showing you for the roof also. Okay, other load I modeled in this structure is the exterior periphery wall load. Okay, which I have not shown in this video. So that periphery load is due to the glass walls which is surrounding this complete building. So periphery as a line load. Okay. So those are the simple gravity loads which we modeled in RAM modeler. Next, let's see how we design the gravity beam design, including the floor vibration check. Notice that we have not performed the analysis yet. We have just finished the modeling, and hence you can see the RAM modeler is showing in green color. Now we are going to go into the RAM steel module to design our gravity steel beams. As soon as you enter your RAM steel module, here you can see the program creates the framings and is now making the program ready for gravity beam design. So first thing you should do is set up a steel design criteria. So I have chosen to use the Euro code and the demand capacity limits. Instead of a unity check ratio of 1, I use 0.9 for both strength and deflection to have some 10% cushion there. And checking the unbraced length, all these are taken care of by the program automatically. Deflection also. We just need to specify the deflection ratios and the program will check for deflection automatically. And camber options also. The program will do the cambering automatically depending on the options that we set up here. And stud criteria. This is required because we use all the floors as composite floors. So the program will automatically calculate the number of shear studs required based on the criteria that we set up in this dialog. Next, we are going to design all our gravity beams. So when I say gravity beam, it's just the blue color beams, what you can see on the screen. Except the red color beams, all the gravity beams are all automatically selected. Just the blue color beams. And the blue color beams, you can see that the member selection is shown there and brackets it shows some number. That number is the number of shear studs. The red color beams are not designed here. They are designed in RAM frame where we do the analysis. So right now we are sizing the gravity beams without doing any finite element analysis. And now we are going to the floor vibration check. So this floor vibration check is a third-party program called Floor Vibe, and Bentley has some agreement with this company to give it to our users. And here you can see we are evaluating the floor vibration check for selected gravity beams, and we found that the design is not sufficient. Okay, and then we click on the advise button for the program to advise us on how to solve this problem. So the program advises us to strengthen the beam, particularly the low frequency beam, and I'm going to now assign a slightly higher section, and then hit the evaluate button one more time, and still the program says that the design is not sufficient. But we are close to 3 heads, so a slight increase in member size should solve the problem. And now you can see there are no more warnings. The system satisfies the criterion. So once we solve this vibration problem, we can pull out a report This gives a detailed vibration analysis report for the gravity beam that we selected. So the secondary beams which were selected by the program, after checking for floor vibration check, we need to modify them to a slightly higher size, okay, which we'll do it later. But now we'll have a look on the reports that we get out of this RAM steel gravity beam steel beam design. And notice that here also we can assign a different section size and design the composite beam, and we can update the database so that the member size will change graphically here. So from UB178, we have just changed one beam to UB203. And now we can pull out a report for the design results for this gravity beam. And here's a detailed report for this composite beam. Here you can see the composite properties calculation and the gravity load combinations and the number of struts required, shear struts, for connecting the steel beam with the concrete above it. And deflection checks are also done. And here's the gravity beam bending moment and shear force diagram. It's a simple diagram. Okay, next let's pull out the summary of our gravity beam design. So here's the beam summary for the roof floor, which is a non-composite floor. So you can see the studs are showing as empty. And here it shows the beam number and the length of the beam and the bending moment and the steel section. Okay, and next for the remaining floors, you can see the studs studs column is filled up, the shear studs. So just in a few pages, we pulled out all the 257 gravity beams in our model. Okay, so we just extracted some reports from our gravity beam design. Final thing which I want to show you of is the takeoff, the steel takeoff for gravity beam. So just this 2 pages report shows you the quantity report, the total weight, as well as the floor wise, the gravity beams. That includes only the gravity beams. Okay, so now let's look at the gravity column design. So on the screen now we can see we have finished the modeling, we have finished the gravity steel beam design, and now we are going to proceed with the gravity steel column design, again without doing any finite element analysis. So on the screen you can see the green color members, which are gravity columns, blue color members, which are lateral columns. Okay, so now we need to make sure we choose the correct design code for steel design as well as the base plate design. Okay, and we just need to specify some design settings, such as the deck braces the column, and unity check ratio, instead of 1 I use 0.9, and base plate optimization criteria I need to fill up. The program will automatically design the base plates for all the gravity columns as well. And now hit the design all button. Now you can see all the columns are designed and are color coded. Make sure none of the columns are showing in red. Okay, the red means the column is failing. And notice that I have set up a limit of 0.9, so you won't even able to see a yellow color column. Okay, so all the columns are less than 0.9. They are selected such a way automatically, and some columns it is showing with asterisks, the unity check ratio with asterisks. Those columns are lateral columns which needs to be designed in addition to gravity loads. They need to be designed for lateral loads as well. That's why they were showing as with asterisks. Okay, so these are gravity, and now we can see both gravity and lateral columns. Now again, we can pull out some detailed results for a selected gravity column or lateral column here. So here you can see, using this dialog, you can see how the same column which is going all the way from bottom to top, how the unity check ratio varies. You can see this column, the unity check ratio for the roof is just 0.22. But as you go down, the unity check ratio increases, the interaction ratio 0.74. And the interaction equation also, you can see at the bottom left side. And we can pull out a report, detailed report that shows the detailed calculation for the gravity columns. This is for the third floor column. Okay, 0.6. So again, here we have option to change the column size and investigate the results further. So those are the gravity steel column design features. Okay, we can now pull out a summary results for all our columns designed for gravity loads. So here's the gravity column design summary. Okay, for each column grid and for each floor level, we can see the column that is chosen, selected by the program automatically, along with the interaction equation and the axial and biaxial moments and the governing load combinations as well. Okay, so now that we have seen the column design, let's see now the most important part of our session today, that is lateral load analysis. So before we go into this lateral load analysis, let's look at our national annex for Singapore. Okay, so the Singapore national annex says that the fundamental value of the basic wind velocity for the entire country to be adopted is 20 meters per second. Okay, this is as per the Singapore national annex. Next, going for the seismic load national annex for Singapore. You can see at the bottom right side corner, the whole of Singapore is under one seismic zone, and the reference ground acceleration to be used is 0.175 meters per second square. This is for the whole of Singapore. Okay, and this slide in the Singapore National Annex gives you the elastic response spectra that needs to be used on the ground types. And note that as per Singapore, we need to use the ground type C, D, and S1 only, whereas the Eurocode, you can see it has starting from A, B, C, D, E up to E, nearly 5 different types of ground types. Out of this, the program Singapore National Annex says only 3 different types of ground types. So this, take a note and then go for our video on RAM frame to apply the lateral loads. Notice that the gravity loads such as dead load and live load, we already modeled that in RAM modeler, and now only we are going to model the lateral load, and then only we are able to do the finite element analysis of the entire building. And here you can see the entire building, and now we can remove all the slabs and gravity members. Now we can see only the lateral framing. So it is this part of our structure that needs to be designed stronger, because they are the one which is going to resist our lateral load. Okay, so these are the criteria. I'm using the P delta analysis for this building. And notice that Singapore National Annex says that you need to do seismic analysis only if the building height increases 20 meters. But this building is not increasing the 20-meter height, but just for demo purposes, I still employ the seismic analysis for this for a 4-story building, okay, which is less than 20 meters. Okay, so here are the gravity loads which are calculated automatically from RAM modeler. And notice that we have option to specify the ground level in case if some of the floors are underground, like basement. And here's the lateral load cases. Notice that the wind load code, we have the Eurocode latest code. And this is the wind load code you specify as per Eurocode 1991 part 14 2005. So here's where I specify the basic wind velocity, which is 20 meters per second. That's all. And the program will generate all the wind loads, all the 6 different directions. Okay, plus and minus eccentricity. Now we are going for the seismic load, the static equivalent method. Again, we have the Eurocode fully implemented here. All we need to specify is the direction, the eccentricity plus and minus, and the site properties where I chose national annex and specify the ground type D for ordinary building, and taken this from the table in Singapore National Annex, taken these values. And here's the design ground acceleration AG. The reference design ground acceleration is 0.175 meters per second square as per Singapore National Annex. And that's it. Press OK, and you can see the 4 different load cases for static seismic load is automatically created. Next is the dynamic response spectral load. Again, we need to just fill up the similar dialog, specifying the AG value, the design ground acceleration on type A ground, and again specify the national annex and spectra values as per the ground type D as given in the Singapore National Annex. Okay, so we have generated the 4 different load cases for response spectra. Next is the IGEN solution. This is required to view the graphical view of the more shapes and also the notional loads. I created the notional load based on the EN 1993 because this is a steel building. Notional loads are important, so I created this, and the program calculate this notional loads automatically. Okay, now I'm selecting all these loads. I'm doing this finite element analysis. So the analysis is completed just in 2 seconds because we use rigid flow diaphragms. Because I'm using composite flows, I specify the diaphragms as rigid flows. Hence, there no need to be meshed, and the analysis completed in just 2 seconds for the 4-story building. And now we are looking at the deflection diagram in proper scale and to understand the behavior of the structure. So here's where I can see the earthquake load in X direction, just scaled 10 times in the X direction and then the Y direction. This is just for understanding the behavior and comparing that static seismic load with dynamic seismic load and then with wind load. So with wind load, when I compare with seismic load, you can see the deflections are very less. So I need to increase the scale to 100 times to view it more clearly. That means what we can understand from this is that the seismic loads are governing much more than the wind loads for this structure. Okay. Next, we can plot other post-processing results such as applied story forces. For example, let's select a seismic load in X direction. We display the magnitudes, the coordinates, and the arrow button, which is shown in the yellow color on the screen. To view it more clearly, I'm disabling all the gravity beams and slabs, so you can see the story shears very clearly. So as you can see here, as you go from bottom to top, the base shears are getting distributed, and the value is increasing. Okay, this is lateral story shears, and now we are looking at the building story shears. Okay, the first one is applied story forces, and the next one is building story shears. Okay, so we can now compare these two on a one screen. Okay, let's just, for example, a wind load. Okay, so you can see here the applied wind load is decreasing as the height increases, or it remains same, whereas it increases as we go down in case of the building story shears. And now what we are seeing is the center of mass and center of rigidity shown in orange color and blue color. The blue color one is the center of rigidity. The orange color was center of mass. And the difference between these two is the one that is responsible for causing eccentricity and torsion in the building. Okay, so now we can have a look on this bending moment diagram, shear force diagram, axial force diagram, torsion diagram for beams, columns separately. So this is the axial force diagram. Similarly, shear force diagram as well. And we can pull out certain reports also. Wait a minute. Before that, let's have a look on our more shapes because we extract the more shapes. And we also doing response spectral analysis. Is good to understand the behavior of the weakest direction of a structure. The X direction is the first more shape, hence that's the first weakest direction. The Y direction is the second more shape, so there's a second weakest direction, and the third more shape is twisting. Okay, so that's what we infer from our more shape diagram, and we just need to look at our other reports such as building shears, and building story forces, as well as the more shapes, participation factors, etc., etc. Okay, so next we'll move on to the member and joint code check. Now that we finished the gravity steel beam design, gravity steel column design, we applied the lateral load and did a finite element analysis. We now just need to show the design the steel standard provisions, because there are many lateral members in our structure that needs to be code checked. Okay, that's what we are going to do now. So first thing is the load combinations. I already created the load combinations, but I didn't show you in the previous video. So I'm showing you to now. So all we need to do is just set up hit the generate button, and the program creates the load combinations automatically. Hundreds of combinations. And again, we can plot the deflection diagram, bending moment diagram for the load combinations. Again, we can pull out reports. Okay. Now let's go for the code checking. Here we choose the Eurocode for code checking for my steel members, and here I perform the member code check. And you can see there are some members which are shown in red color. So I need to check that, increase the member size for those members. Okay, so this is a color-coded report index that shows very clearly the members that are passing and the members that are failing, and members that require special attention. So here you can see this member fails in 1.04 ratio, so a slight increase in section size should solve the problem. And this detailed report shows you the interaction equation, lateral torsional buckling check, and all other detailed checking. So this is the governing equation which gives the ratio of 1.04, equation 6.41. Okay, next we'll go for connection design. Now that we finished the steel code checking, now the final thing left over is the steel connection design. So directly from RAM structural system, I'm launching RAM connection program, and RAM connection reads the complete 3D model along with the forces, member end forces that is required for the connection design. And here I'm isolating the lateral members. Okay, I'm unselecting the lateral members, which are shown in red color. Unselecting. Okay, and then use the option to reverse selection so that only the unselected members got selected. Okay, that's the lateral members. And now we are looking at only the lateral members. And now we need to assign the connections for all these lateral members, which are the important moment connections. The rest of connections for all the other hundreds and thousands of gravity members are simple shear connections, which we'll look at it later. So now I'm choosing the design code as a Eurocode, and choosing the load cases for which I want to design, which is in this case is only load combinations. And I'm going to basic connections, basic end plate connections, extended end plate connections. And now you can see all the hundreds of connections are designed in one go. And there you can see a gusset plane kind of symbol. Let's take some random connection and double click it. And there you can see the 3D view of the connection, moment end plate connection, which is actually failing. 4.49 is a ratio. We can now look at the ratio, the results for the connection design, and find out the reason for the failure. Here you can see the hundreds of load combinations. So here's where the main pain point of the structural engineer is getting resolved in not putting in all these governing load cases in a different program. The interoperability between these two programs takes care of that and designing for the worst case. So here are the geometric considerations, which says that the bottom flange flush section length is not enough, and then the moment resistance of the joint is also not enough. Okay, so there you can see the capacity of the current joint and the demand. So that is the only two things that we need to fix in this connection. Okay, geometric consideration and design check. So all we need to do now is just to use this connection pad on the left to add a mini haunch, okay, to increase the moment capacity of this joint. Okay, and that haunch I'm going to make it a little stronger by using a bigger T cut from UV section. There you can see graphically in 3D view, and the ratio now reduces from 4.5 to 2.34 and still reduces to 1.42 as we now increase the haunch size and put in some bolts. And as I increase the height of the haunch, you can see the ratio now reduced to 1.07. And then by choosing the correct grade of bolts, I optimized it, and now we can see that it shows in green color 0.86. That means we successfully designed this connection. Okay. So now I'm trying to optimize by using a lesser bolt size, but that doesn't help. So I go back to the 24 mm bolt, grade 10.9, EM24 bolt. And now I'm trying to optimize the number of bolts. Okay, so all these are user controls. And now that my connection is successfully designed, now I can show you the detailed drawing, and I can export this detailed drawing in a DXF file. And now I can show you the stiffener options. Even though the stiffeners are not really required for this connection, I'll utilize this opportunity to show you the options to model stiffeners in this model. So here you can see I model the transfer stiffeners, and there's provision to model column web panel stiffeners, such as supplementary web plates to strengthen the column web, or diagonal stiffeners. And whatever changes we do for the stiffeners, you can see the detailed drawing is getting updated automatically. We can even add the rib stiffeners also. And again, the detailed drawing will get updated automatically. But all these stiffeners are not required for our connection, but just for demo sake, I show you this capabilities of this program. Okay, so with this haunch, mini haunch, we are able to successfully design this moment connection. Okay, we can copy the same connection for the rest of the connections, or we can design the rest of the connections individually also, the same way. Now that we designed our lateral, the connections for our lateral members, now I'm going to show you how to design the shear connections for the rest of hundreds of the gravity beams. Okay, so now I'm selecting only the gravity members, which is made of columns and beams, hundreds of columns and beams. Elevation view and then the isometric view. Notice that I removed all the the lateral members from this model for visibility sake, better visibility sake. And now all we are viewing is gravity members, okay, which is the majority of our building. And I'm just assigning a simple fin plate connection for all these gravity members, which is cheaper and easier to construct on the site. And now double clicking one of these shear connections, you can see this connection is connecting only the web of the beam. Shear transfer that's capable of taking only the shear forces. And here's a bill of quantities. And here's the step-by-step calculations. And you can see that the forces that are considered for this connection is only the shear forces. And those are the design checks and the geometric considerations. We can also view the formulas in case if you want to check it manually. Okay, so we now learned how to design the thousands of connections in one entire building, which involves moment connections for our lateral members as well as shear connections for our gravity members. Highlighting some of the members in 3D rendered view, you can even see the connections in 3D. Okay, so there you can see both shear, the gravity connections, shear connection, as well as the moment connection on the right side. Okay, so now that we designed the building, analyzed, designed, even the connection, let's see the detailing features of this program. Okay. Very quickly, we can use this DXF options in this program to export the framing, floor plan, etc. Choose a suitable scale, assign a layer and color, and the layer name. So all these layer names will be retained in the DXF file, which you can use it for editing in your CAD program. Okay, so I fast forward it. We pulled out some floor plans, footing schedules, and these are the outputs, which you can open it in MicroStation or any CAD programs. Column schedules. Floor plans with the labels. Next, BIM interoperability. BIM interoperability is needed for several reasons. For multidiscipline coordination with architectural, structural, mechanical, electrical, and also for pulling out various multi-services drawings that may include structural plus other disciplines as well. So here I export a ISM file from RAM structure system. And after I successfully exported the ISM file, I open Bentley Open Building Designer. And here in the analysis menu, we have this ISM repository, new from repository, and I import the ISM file from RAM structure system into Open Building Designer. And the same process is for Revit as well. For Revit, you just need to install the free ISM plugin. You can Google search and download the plugin and install it on your Revit computer and use the same process. And the complete 3D building model, which we modeled in RAM structure system, which we finished the analysis and design, is now coming in the BIM program. And just few more button clicks, you can pull out some useful reports. And you can see here the composite flow, the cross section of the composite flow detail also is imported correctly. Now let's create some column schedule in Open Building Designer. Those things can be done in RAM structure system also, but if you use a BIM program, you'll get it in a much better detail. Okay. So I just click a button in Open Building Designer, and here's our column schedule, the steel column schedule for the entire project. Okay, so like this, we can pull out many such reports in the BIM program, including quantity estimation. So I have finished my presentation for today. And to summarize, a structural worksheet is not a product, it's a special bundle license of 8 products from STAR and RAM brands. And today's presentation, I covered RAM structural system and RAM connection. If you're looking for a concrete building, I already did it last month. And if you need a link for the on-demand webinar, please inform us. We can pass you on the link. Some other day, we'll look at the other programs. Okay. So the bigger picture here I put in addition to RAM and STAR, I put in the other programs of Bentley such as SACS, AutoPipe, and Flexis, geotechnical pipe stress analysis, offshore structure analysis, as well as our open plant program for the plant modeling. And together with the Open Building Designer for multidiscipline building information modeling and Pro Structures for detailing. And our competitors turn out to be Partners, Tekla Structures, and Revit. To summarize, completing a steel building design project requires several software varying from BIM modeling, structural analysis, design. When I say design, is member design, connection design, foundation design, so and so, detailing, and quantity estimation programs, quantity and cost estimation programs. When I say detailing, it involves simple design drawings plus complex shop drawings as well. The structural worksheet gives a bundle license which helps complete the project with one license. Of course, that doesn't include Pro Structures for shop drawing. That doesn't include Open Building Designer for BIM modeling. Okay, So this structural worksheet includes only the structural analysis program, 8 structural analysis program. So the ISM technology helps in interoperability between the structural analysis and BIM and detailing programs. Okay. So with the help of Bentley structural worksheet, we can finish our steel building design project more efficiently at an affordable software cost. That includes connection design program, foundation design program, in addition to general purpose and special purpose structural analysis programs. Okay, so we have a YouTube channel called Bentley Structural. If you're not subscribed already, please subscribe to it. We have several useful videos there to learn, and all our learnings are available, trainings are available in LAN server, free of cost for Bentley users. On-demand trainings for all our programs are available there. And after completing the training, you can even print out a certificate. And to get support from Bentley, you can reach out to communities.bentley.com. There are forums, blogs, wikis, and examples are available there already. So 95% of the questions you ask are already answered there. So instead of spending time on raising service requests or emailing us, I would suggest you to first visit our communities and search for your keyword in our forums, and you can see your question may be already answered there. If not, you can post your question in the communities forums itself, or to get one-to-one support, you can raise a service request using this link, bentley.com/service request manager. Connect Advisor opens up automatically when you open any of our Bentley program, and advises us the ways to get support and the new videos that are posted in our LAN server and our YouTube channel. So with that, I conclude my presentation. Before we open up for our Q&A session, I would like to do some 2 more polls. Okay, this is supposed to be before the presentation, but doesn't matter. What is the connection design program that you use in your office? Okay, so please help us in joining in this poll to get an idea about our audience. So I listed some of the commonly used connection design program in this region. Wow, majority of you say others. 63% of you say others. That is interesting. I'll keep it for another 5 seconds for you to answer this poll. So 60% of you voted. So I suggest you, more of you, to participate in this poll so we get an idea about the type of audience today. Okay, thank you for participating in this poll. So I close this poll and move on to the last poll for today. Now that you have seen this presentation involving RAM structural system and RAM connection, this is a specialized program for building design. Would you like to use this workflow in your future projects? So please help us in answering this poll. When I started the presentation with a poll, many of you mentioned that you use a general purpose program like StatPro for designing steel buildings. But notice that StatPro is a general purpose program. That is its advantage as well as disadvantage, because it's not specializing on building type of structures, whereas RAM structural system is fully optimized for building. The application of lateral loads and the concept of gravity and lateral load modeling, lateral member modeling, is not available in StatPro. Whereas in RAM structural system, it is a unique feature which helps you to optimize your steel building much easier, designing most of your structure as gravity and only few lateral framings on each direction that requires expensive moment connections. That makes the design more efficient performing building and more cheaper structures. Okay, so thank you for participating in this poll. So I conclude this presentation. Now we can open up for a question and answer session. So using the Q&A box, you can post your questions. So if you have any questions, please type in your questions in the Q&A box. I don't see any questions posted for now. Swarup, if I miss out anything, yeah, I can see those questions now. Let me view it in a bigger view. Okay. Okay, one of you asked, what is the best optimization ratio? Okay, for initial design, I would keep the optimization ratio as 0.9. I understand what you mean by optimization is the unity check ratio, isn't it? The interaction ratio. So usually by default is 1, but usually I change it to 0.9 so that for initial design, I'll always keep some cushion of 10%, so that will be useful when I finalize the design later. After modifying the connection, how to apply it all other similar connections. Okay, so when you assign the connections to the building, there is an option called design connections individually. If I don't click that option, assign connections individually, the program will try to assign a group of connections, same connection for all the groups. But those connection may not pass. So as I shown you in today's presentation, we have manually made it pass. But after we made it pass, we can copy that connection for the rest of the connection and do the checking one more time. Okay. Next is, can the RAM connection be used to design for channel member connection? Yes, that is a new feature in the latest version of RAM connection. So please make sure you install the latest version of RAM connection. If you're already using RAM connection, the latest version has the feature to design the channel member as beams in the connections. Okay, hope that answers your question. I need the link of the previous webinar, so I will pass it on to you later, which is a concrete building webinar. Okay. Can RAM connection check and give warning if the bolts are too close? Yes. In addition to design check, the program also do the geometry check that involves the spacing checks and detailing checks. Yes, that if these bolts are closely spaced or overlapped, the program do give you a warning message in the report. Remember, in my example, it showed me some warning message for my the length of the edge length of my end plate was not enough. So all the geometry check the program will do as per the code. Hope that answers your question. How to steel connect to pile cap? So the steel column, you are designing the base plate, isn't it? If it is a gravity column, the RAM structure system program itself can design the gravity base plate. And that base plate, you need to sit on a concrete pedestal or directly sit on the pile cap, okay, depending on how you want to design. And that pile cap will be supporting the base plate from the steel beam, and that's where you're placing your steel column on a pile cap through a concrete pedestal through a base plate. Okay. Hope that answers your question. In the applied connection, should we can release a member in modeling? Yes, RAM structure system has the member release commands, same like StatPro. But most of the time we don't need to do that because the ability to model the gravity and lateral members automatically takes care of the majority of the releases. The gravity members will have moment release applied to the ends of them, end of those members, whereas the lateral members don't have those releases. So in addition to that, manually also we can assign those releases. We can use RAM foundation. Yes, the reason why I didn't show today for foundation design using RAM foundation is because the Eurocode is not available for RAM foundation, whereas the other modules in RAM has the Eurocode. It's only the RAM foundation module does not have the Eurocode. So if you're following the ACI code, then you can use the RAM foundation itself to design the foundations. So the March month webinar, I did the same webinar for American codes. So at the time, I used RAM Foundation to design the foundations because it's by ACI code. For Eurocode and other codes, I would suggest you to use the RCDC program, which is part of Structural Worksheet, to design the pile cap based on Eurocode, Singapore National Annex, or Malaysia National Annex. Okay. So that's why today's presentation, I didn't show you RAM Foundation because today's presentation is focusing on Eurocode. Okay, so some of you are requested the link for the previous webinars. Yes, we'll do that, send it to you later. Yes, sure. Okay. I don't see in your explanation about connection to pile cap. Can I have it? I don't understand what you mean by connection to pile cap. the steel structure which I explained today, you see the foundations are all pile cap. I didn't show you the pile cap design today because this seminar today I can't cover many things because today we are focusing mostly on steel structures. The pile cap is actually concrete, which I covered in my previous last month webinar. Okay, and the connection to pile cap from your steel structure, the connection is through the base plate. Hope I answered you. If I couldn't answer you clearly, you can email to us separately. I can reach out to you. We can have a separate conversation. Okay. How to add pile cap to the core wall? Maybe not relevant to today's. Okay, so pile cap is usually assigned for columns. For core wall and walls, if it is a straight wall, if you watch my last month webinar, you can see the answer to this. For single walls, I use a combined footing. Okay, and for core wall, like lift core, I use a mat foundation, and that mat foundation can be a piled mat foundation or a soil supported mat foundation. So please watch out my last month webinar to see a more detailed presentation on that. Does RAM connection design moment connection on both sides of the column and check the column web and flange buckling concerns? Yes, RAM connection design moment connections for both sides of the column, but you need to design it one by one. Okay, and you check for the column web and flange buckling concerns. Yes, that's why we need to put stiffness. Okay. Is there any available source for us to learn more about RAM connection? The right source is learn.bentley.com. That's where you can learn RAM connection as well as all our RAM products as well as STAT products as well. Okay, so on the screen I'm showing you this LAN server. I'm not sure you're able to see my screen, but I did show the LAN server screen in my presentation, and also YouTube video. Okay, so you can see the LAN server on my screen. Okay, so use this LAN server to get trained on all our products free of cost. This is freely accessible to all our Bentley users who are on a select subscription or Virtuoso subscription. Why should we choose RAM over other connection design program? As you can see in my today's presentation, I use the integration between a structural analysis software like RAM structural system and a connection design software like RAM connection. I had hundreds of load combinations. If I don't use RAM connection, if I use a third-party connection design program, which doesn't have integration with RAM structural system, I need to find out the governing load cases. That itself is a big task, isn't it? And sometimes for designing a single moment connection, there'll be multiple load cases that may be governing. One load case may be governing a moment, and another load case may be governing the shear. So for that, the integration between a connection design software and a structural analysis software is very, very important. So that's why I strongly recommend RAM connection program over other connection design program, because RAM connection has tight integration with both RAM structural system as well as STAT Pro. Software for students, please reach out to our Bentley academic team. I'll link you with the Bentley academic team who will, can respond to you, because we have a separate team for handling the students and universities. Okay. Where can I find next webinar? The Virtuoso website will give you the details about our next webinar. We can do shop drawings when all designs are done by RAM software. Okay, see, shop drawings, when it comes to shop drawings, we need a specialized detailing software like ProStructure. So that is not part of structural worksheet, but that is part of Bentley products. So using the same ISM workflow, I can, just like I showed you how to import in Open Building Designer, I can import the same method using ProStructures program. And that's where I can produce all the shop drawings. But if you are looking for only connection details, that connection details can already produced by RAM connection software. Okay. How about tubular connections? So tubular connections are all supported in RAM connection. Tubular sections as columns is supported well, and tubular to tubular connections are also available in RAM connection. But the tubular to tubular truss type of connections are available only for American codes right now. It will be implemented for Euro codes very soon. Okay, hope that answers your question. What are the difficulty of using RAM? I don't understand your question. There's no difficulty in using RAM. You just need to get trained on it. So utilize our LAN server to get trained on our RAM products. And if it is a building project, a commercial building project, steel or concrete, I would strongly suggest you to use RAM brand of products rather than a general purpose structure analysis program. Okay. BOM, bill of material. For connection design, yes, for RAM connection can extract the bill of material for connections. If you're talking about bill of material for steel sections, yes, the program extracts the bill of material, which I showed you in today's presentation. If you're talking about the quantity for steel, concrete, for concrete building, I showed you in the last webinar already. Okay. Yes, bill of materials can be extracted. Even cost estimation for concrete buildings can be extracted in RCDC, which can be linked with RAM structural system, which my previous webinar explained it. Okay, so we have well exceeded our today's limit of presentation. So I'll hand it over to you back, Swarup. You can conclude this today's webinar. Thank you.
Yeah, thank you very much, Madan. Yeah, it was really exciting, I believe, for today's presentations, and the Q&A session, I think, was quite helpful. Okay, before we conclude, there are some announcement actually for the audience. Let me talk about this YII 2021. Yeah, this is the Going Digital Awards in Infrastructures, which formerly was known as the Year in Infrastructure Awards. So this is an exciting and well-regarded global competition which recognizes digital advancement in the infrastructure. Since 2004, the awards program has recognized over 4,000 of the world's most outstanding infrastructure projects. So now it is open to all Bentley software users. It's a unique program that's truly global in scope and comprehensive in all categories and in all form of infrastructure projects. So nominating your projects actually give you a great recognitions, exciting rewards, and unique opportunities to network and promote your organizations. All finalists will present their projects at the Year in Infrastructure 2021 conference. Nominations are open and submissions deadline is 4th June. Feel free to contact us. There could be a lot of questions and you want to know how can I get the softwares, or any technical questions also you can ask, commercial, any question you can ask. Well, there are some special offer is also there. You can approach me or any of our colleague here. In these regions, for Southeast Asia, Darius and myself, Swarup, our email address is given on the screen. My email address is swarup.mandal@bentley.com. And for Australia and New Zealand, you can contact my colleague Theresia. And for India, you can contact Priyanka Pal and Rajarshi Chakraborty. And I think a lot of clients also would like to know when is the next webinars. Yeah, we have conducted previous webinars on RAM connections and also the essential modeling for concrete structures. You can go to the link below that's provided, go.virtuosity.com/structural analysis webinars, or you can just look at the QR code next to it. So it's easy for you to find out. And the next webinar on essential modeling for steel structures, that will be on 23rd June. Singapore time will be 2 p.m. Yeah. And at the end of the webinar, actually, there will be some quick survey questions. So that will help us to survey better. Please participate in that. And that's all for today's presentations. And on behalf of Bentley's and Virtuosity team, we would like to thank you for joining us, and see you at the next event. All right. Thank you so much. Have a great day.
Thank you all. Bye.
Thank you.